more of those.
I mean, it's a top class. Okay, I'm going to take 5 minutes to discuss with you about this project work. Okay, so everybody's here? Oh, the rest are still in the toilet.
Some missing.
Quite a few missing. In the toilet. We'll wait for 1 minute, toilet break. Okay, I'll start so that I give Dr. Tan some time. Okay, so as you know, we would like you to think about our project. This is a part of the learning that we want you to do. So I think number one, why we are doing this, because we want you to learn how to collaborate and work together. When I was studying at Northwestern University at Kellogg Business School, one of the things they teach us is that, every class, you can never do your paper on your own. You either have to work with 2 or 3 people. That means you write a joint paper. You joint project together. And the reason some of the students were not very happy because they, why can't I do it? The reason is because they said, in life, you always have to work with people. Whether you are the boss, subordinate, or peer, you work. So you better learn how to work with people. And then some people complain, now what if one person gets lazy and that's your job? This is the whole idea of trying to get everybody to collaborate. And then secondly, we want you to, most importantly, to apply what you have learned. So we have completed 4 modules. After this, I'm going to just ask you by raise of hand some of the modules that you are more interested in, and then maybe you all can group together based on the module. And of course, more importantly, is to reinforce learning. Nothing is best learned until you put into practice. So this is the whole idea, so that you take a topic that you are interested in, and then together you collaborate and work on the topic. So how is it going to be done? We are looking for a team of 4 people, 4 people in one team. Then secondly, you select one of the 6 modules. So by now, we've completed 4. There are 2 more to go. One is on crisis and the other one on cross-cultural management. So we want to discourage that you try to apply, the most important is to apply what the topic into your organization, okay? So what I like to do is, maybe by next module when we come together, I would like the group to be formed, okay? So just let me answer by raise of hand, how many of you are interested in doing something on energy? No energy people. You have no more energy. Really? How many of you are interested in safety? 3. Okay, so safety. Then the other one is
Innovation.
innovation. 1, 2, 3. Okay, so yeah, so 4 of you. Wow, so maybe you
Innovative
safety.
safety.
Innovation safety.
Okay. All right. So then, how about energy safety?
Today's
Today.
Today what?
Internet of Things. Wow, so maybe wow, my goodness. So popular, okay. So maybe we can have 2 groups of that. How many are interested in crisis?
crisis.
Haven't gone through yet.
No idea at all.
No idea, okay. All right. And there will be prizes for the collaborative project. And I've given you sort of project report, okay? The outline, what we are looking at. And what I would like you to do is maybe by next module, the 4 or 5 of you get together and try to determine roughly a project. The project must be, you must take the topic and apply into your organization, one of your organizations.
Confidentially.
Huh? Confidentially. Then how? It will be confidential as far as the AELP is concerned. We will not go and post it in the internet. Mervin, what do you think? They are afraid of confidentiality.
How to address this issue?
But I think if you are doing something good for your organization, why, we'll be within the purview of the.
Data from the company, you can.
Yeah, we don't go and. Yeah, okay. Maybe the idea is this is only this project for your company. You, those of you who are involved, don't take it to release it to other people, if that is your concern, right? So this is roughly the thing, and I would suggest that you think about it. So you see your colleagues, so you get together within the week and say how we going to work together on this particular project. And depending on time, maybe we can even do that today. Maybe after the class, you all can get together and start brainstorming a little bit what you all have in mind, and how you're gonna, which organization you are thinking of to apply. Okay, so there will be prizes, the top 3 prizes, and January 16, you will be required to make a presentation to the judges. And the judges will be selected by the IES Advisory Council. Yeah, Mervin? Correct?
Yes.
Okay, so that's all I have to say.
Okay.
Dr. Tan, thank you.
Okay. Back, let me just start. Give you 2 types of business model where I see in the Smart Nation, Internet of Things come up. And this business model is not new. The first model is basically just purchase. I think most of you have experience inside there. A purchasing model means actually it's a buyer's headache. Means whoever buy it got headache. Okay, let me explain to you. You raise a PO, you need the boss to sign a PO. After giving the PO, the buyer, before they give a PO, you're the king. When you give the PO, after you give the PO, the buyer is the king, the other way around. It means that before you give the PO, you can select the vendor. After you throw the PO to the vendor, actually he is the king really. Are you aware? It flips the other way around.
Like renovation.
Huh?
Renovation.
Same. So every contract you have to watch it like that. Then after the 12 months warranty, all repair costs and delay is out of your hand, right? Correct? Because after warranty, I charge you whatever money you want, you have to pay because you already bought the equipment. Right? So the difficult part is the buyer's model. And after you give the PO to your vendor, and if it doesn't work, can you go back and talk to your boss? Say, boss, actually this vendor no good. The boss will ask you, who select this vendor? You. So you also get stuck, correct? So either way, this model, people are getting into a different mindset. Especially you buy something which is innovative. Okay? If you buy a table and chair, I think it's very clear. The spec is very clear. The other one is that what happened? You spec it wrong. You quickly, quietly put it there. But your boss also will not tell his boss. Also, he quietly put to one side. Until after the book value becomes 0, then you write off, correct? It happens in every organization, correct? No. You see, this is not new. When I was in Philips, I had the same problem. Okay, that was in the 80s. So today, I also see that happening. I don't think it will go away because we use a purchase model. You see, when you buy something, you have to be sure what you're buying. But if you're buying something like this, then there's no innovation. I just buy it, right? Don't work, throw away. It's cheap. But when you buy a machine and equipment, which is very complex, if it doesn't work, what do you do? And nobody wants to surface to the boss that actually it's a mistake. Your boss also don't want to surface. Your boss also don't want to surface. So in the end, we find a storage and we keep it there. After book value 0, shoop, it goes. Okay. But that model is changing to this type of model. Don't work, don't pay. Or another one, they call it public-private relationship. Or the other one you call supplier and your customer relationship, collaborative. So it's a joint risk, okay? And you treat customer as a king because it pays only for things which work. So this model is changing very fast and you see happening. I will give you some example. So I always use this example. You send your car for servicing and after service, we send your car for servicing, I phone you, say, hey, your car, when I step brake, got squeaking sound. The next question you ask, what happened? I said, your brake pad, I think it's not so good. But you can still drive, nothing wrong. Then what are you going to do? How much it costs to fix it? I said $500. Then we negotiate 400, right? When you go and collect the car, are you sure it's this pad is from your car? You can't tell, right? So what it means, you only can negotiate price. But as a service provider, I hold you, actually. Because you do not know enough. But in that transaction of just buying and like that, you actually got no control. A different model where it is less risk for everybody is actually buying a service model. That means that pay per use. Your mobile phone is actually pay per use. This is what you can relate, correct? Mobile phone, you don't buy actually a complete model. You don't buy a phone without the SIM card service, this phone is useless. Only can play games. So actually it's a service model. So it's not new. In other industry, they are using it. So I will share with you the business model and why it is good. Okay? But there's also a flip side. Okay. Case A, you own asset. No known available solution. Okay? That means that you and is high risk, unknown, innovative. So the reason behind that when you own the asset, sometimes when you go into something new, as high risk, innovative, it's very difficult to own asset. You own what? Okay. So let me share with you one example. This is a real project. All these are real projects, which is the project I used to do in my business. I show you how complex it is. Okay. And because it's complex, the customer actually didn't know how to spec. And for me, because the customer wants to buy, I sell. But I know they cannot maintain. Okay? But I'm there to make money. So I don't want to tell them what they don't know. It's not my job to teach my customer to make money. I just want them to pay me. Okay? So this is a real project. This is biometric identification on motorcycles. Is people counting. That was the company I started. And I was a vendor to NEC. NEC is a main con to ICA. This project is an automated immigration clearance system at Woodlands and Tuas checkpoint. What you do is that if you are a Malaysian motorcyclist, you come to Singapore, you take a passport, you must put your fingerprint. Then it clears you. all motorcyclists do that. Now, then they want to automate the system using a gantry, so that you automate, so you don't need officers sitting down there. Or else you have the officer check your passport, scan everything. The problem is that in this environment, nobody who is highly educated to a certain level wants to work over there. First, a lot of government monocycle. In the morning, thousands and thousands of motorcycles come in. Then in the evening, thousands come back. So they have two peak periods. The officers work in the morning and evening, but they have to pay overtime, because the morning one is about 6 o'clock and 8 o'clock. Then the other evening is the other side. So you cannot have one officer. So they split into two. So the workload you cannot balance. Then after the peak load, the officer is very free one. So they have a problem trying to balance the workload. Okay. So in the bike system, my job was to count number of people on the motorcycle. So if there are 2 motorcyclists, they expect 2 passport, 2 fingerprint, correct? So is one fingerprint, 1 passport, unique. And of course the passport and the fingerprint must tally together in a back-end computer system. But that part is done by NEC. My job was to count automatically when the motorcycle in, how many people on motorcycle. That's all. Sounds very simple. Okay. So when I first started the POC phase, we use cameras. That's a very classical method. Put the camera, analyze one person, and human detect. So this is the part, the first phase of POC. They use a biometric, and the camera was there, so they count. So you look at this accuracy, lane 36 and lane 38. The accuracy for different months go up and down. And let me tell you the truth, it's not like that, it goes. But when you average it, you don't see it. Okay? The problem is that when he's giving all the error, they could not stabilize. But at that time, there was no specs given to me. They said, can you get it to work? So I said, get it to work. They never asked for accuracy. So I said, this no. So because they don't know what they don't know. Of course, I also don't know what they don't know. So how can you call a contract a standard spec where both sides don't know what they don't know? So they can't specify. So when they can't specify, okay lah, I also cannot, then we collect according to functionality and how many computers there, camera have. So, but this is a POC system. So there was about, I think, about 8 systems. Okay lah. But then they want to learn, we also learn, then to move on to the next phase. So the camera system has a lot of problems. Okay, let me explain to you. When you put a camera outdoor, there is a problem of light intensity. Sunrise, sunset. So when in the morning, the sun rises from the east, and then when the sunset it goes to west. So the light intensity changes because you have incoming and outgoing at different parts. So there were a lot of lighting problems. Okay, you have put shade, all that. Too complicated. So in terms of technology, really they are unknowns. But after we did the project using cameras, we found that actually it's not good. Okay, so you can see from camera, we actually make it into a color to basically monochrome. But it's not accurate. See, 99% accurate, but not all the time. It varies from 96 to 99.5. So if I choose the correct result, I'll show 99. You choose a different data, all wrong. So how to handle that? Because you cannot have automated system where it's not repeatable. Remember I told you, this can function. Performance a bit not so high. Reliability also have. Then don't cost about the rest really. Okay. Functionality, these are the problem. But you cannot automate because their idea is to automate everything. Now, then after that, they form a new tender spec. This is the second part already. Okay. The new tender spec they want to have is 7,500 for Tuas, but the real volume is even higher than this. This is just a test case, so they have about 26 booths. They call the second phase because there is no known solution. That's a problem. Okay, so one error means you have to handle this capacity. Okay, in the tender spec, they ask for 1%, 99% accuracy. It's in the tender spec. So I told them, if you want that, you better specify. But in the beginning, they don't know what to specify. I said, because in the first phase, in the POC, if they specify, I think I also Darren do, I don't want to do, Darren do, because I don't know what's unknown. But after that, they discussed with me, what is the spec you can handle? I said, okay, 99%, I'll try. But I can tell you, I don't even know what I can be done. You say, can't, 99, okay, do, like that, you know? Just like that.
What does the 1% stand for?
Means when you send in 100 bytes, if one byte cannot detect, it's acceptable. Wrong reading. Okay, wrong reading. So if you are 2 person, for 1 person, for 1 byte, I detect 1 person when it's supposed to be 2, then okay lah.
Yeah, it's not a case of the overall miscount by 75 people, it's okay. It's per byte, per byte basis.
Per byte, yes. Okay. Now, so for me at that time, I have to change my technique, but I never explained to ICA that I was going to use a laser. If I tell them the laser, they will put in the specs, so my competitor also knows use laser. So I tell them, oh, it's a contactless system. You put camera, I said, as long as contactless. So I said, as long as I can deliver 99%, why should you care? So for them, they put. So in the end, I use a laser, because the laser is not affected by light. So 20 meter. So how it works is that this laser scan, I can measure the distance. Okay, how it works. So this part is an innovative project. Okay. Some of the problems I encounter: non-standard communication, laser reflection, product support. Because they want this laser, they want this to last about, I think, 8 years to 10 years. I cannot guarantee. Of course, in the tender, I just signed 8 years. Okay. So, example, this is a reflection. So when the lasers detects the motorcycle, you get a lot of reflection, that missing points. So what we did was that when you have missing points, how you reconstruction. So this is a very technology intensive sensor. So in IoT, there's a lot of signal processing requirement. You process the data. Example. So when you have laser, we point dot. So we got missing data. So what we do is that we use two-dimensional polynomial discrete speed. So when you do a curve fitting, you synthesize more points. So in the linear graph, it's like that. So we use the polynomial least square speed. So by doing, we synthesize back the point. And how we correct that? You can see the raw data with missing points white. So when we curve it back, it becomes more solid. So this is the type of problems in Internet of Things. You have to find solution. It is not the standard that until you face a problem, you say, oh shit, how I solve it. So you need engineering knowledge to be able to handle those techniques. So for some of you, you learn curve fitting, you use curve fitting, all these methods in your school, but you never imagine it's used for that. So that's what engineering is for. Okay. So then after you curve fit already, how you tell a human looks like? Okay. So we need a human detection algorithm. You get all the data. You as a person can tell it's a human, but how you tell a computer is a human? Okay. Okay. So then the question comes: is there a standard model for human features? What do you look for in a human? So you go back to very basic question. When the computer can scan you by laser, how you interpret? Can this achieve 99% accuracy? Can the technique handle the load? It means that a lot of motorcycle comes in. And this morning you can see that coming into Singapore like that, huge volume. Okay. And how you handle exception. So in every system design, you need to cater for exception. Because you are working in real environment. Real environment is never perfect. You have to design a system which must take care of exception, or else the system just crash. Human detection, performance, and how fast can it count? Per day, we have 620,000 files. Huge capacity. Okay? And how much time to tune to 99%? So it's a lot of work. So example, so when you get the laser to run with all the interpolation, you have y-axis view and vertical axis view. You see all dots on it. From a human eye, you can interpret, right? there's a box, there's a human, two person in the front. This is Z-axis, Y-axis. So my guys, my engineer very clever. You don't put like that, you put an angle. You put an angle, you measure Z-axis and the horizontal axis. Because the human is symmetry. So we create the duplicated image on the other side. Okay. Then after that, we truncate the lower portion because human below we are not interested, we are only interested in the top. Okay. Then after that you can see from there, those human dimension is too thin, we remove it. So that's how you count. Because the human has a physical dimension and your head has a center. In the center, with respect to your shoulder, there is a certain dimension, cannot be your like giraffe, correct? Or you like dwarf, correct? So this is how we translate from data to information. That's what I mean. That's why I use this example so I can explain to you how to convert raw data to information. Raw data means all these dots. But how you tell the computer? A lot of numbers. So the computer in the ICA computer just want to put 2 person or 1 person or 3 person. So we use that method. Then you can see we convert. Then we have things which fail. You remember I discussed what's fail. You get into this sort of picture, you cannot count, you see like that. It looks very strange. Hey, how? Why? Is it laser problem? Is it this problem? Because you see, if you have 1%, when you detect all this failure, how you solve this problem? Means things which don't work is actually very important. Because that's how you learn. And when we first started this project, when we faced all these problems, as we expected, I have electronic engineer, signal processing engineer, we all went through a software algorithm, everything. So in the end, my most junior staff on site told me, say, boss, simple problem. See, because we're all engineers, we all go and think, sit down, think algorithm, don't know what, is this hump? So what happens is that when the motorcycle go through the hump, the motorcycle move. When you go through, so all the numbers will go wrong. So the trick, just move the hump back. You see, what I mean is that because we work in our domain, we all know our stuff, we look for solutions in our domain. But when we talk to our site staff, the site told me, say, this one is because of bouncing lah. Then after that, we just ask ICA to shift the bump backwards, finish. So you see, if you don't listen to people, talk to the ground, you will think you know your stuff. You will think that your solution got this problem, when actually it's a very simple problem. Move the hump back by half a meter. And it's so easy to fix. So what I mean is that be open-minded and listen to the ground. Remember I told you in a hierarchy system, the boss knows everything. If I run it like I don't think I can solve. Say, oh no, you try harder, change the software, change everything. But if you listen to the ground, you get all the solution. Okay? So this is an example. Some of you must have heard. If you are a hammer, every problem you see looks like a nail. Because that's what you are. A hammer will ever see everything is a nail. So exactly this, I'm trying to explain to you. In a complex project, you have to be multidisciplined and you have to listen to your staff on the ground if you want to get problems fixed. So there is a need to go to areas which you are not familiar to look for solution. You must accept. And the mere fact you have a project team here who are technical and you got a site team who is not technical doesn't mean the solution cannot be found there. Because you'll be very arrogant to say that this project team knows everything. That's not true. Okay, just to share with you that it was something I learned. Okay. Now, then there were also lasers when we measure. This was good, and suddenly all these lines came out. We couldn't figure out why. We thought laser defective, correct? But actually it's not. When they replaced the string, they moved the laser. So when the laser is shifted on the graph, on the laser, it measures the graph. November, and 2011, 2010 is shift by this dimension. So in there, certain times when we saw this graph, we also couldn't understand. But by talking to the people, because you see, the group which was designing was software, electronics, all that. So this one was found out by my people on the ground who's doing installation. And they tell me that it's moved. So that's what I'm trying to explain to you. Do not rule out things you don't know. Do by talking with people on the ground. You will learn a lot of things. Okay? So, image-wise, counting, you see from here, it's so easy to, your eyes can see it's a human at the back. Then we convert it there. But to tell a computer, it's a lot of work. Okay, 2-person. Okay, the bikes came out in newspaper. The full system came out 18,000 motorcyclists a day. Going in, after going back. And this is not the maximum yet, still got some more. They're increasing it. Because our currency is 3 times, so you find actually a lot of Malaysians to all come to work. Just to share with you, this is actually is because they have to automate, they got the whole thing jammed in the causeway. Okay, so for the case B is another way where I also do. The case A is just buy and sell. So for me, it was because it was a contract, I buy and just sell, finish, collect money and run away. But that sort of business is a business where I think is opportunistic. This sort of business is more scalable. Let me explain to you. I'm the supplier, you buy service. I invest in equipment. You don't have to think about equipment. Any problem equipment is my responsibility, not yours. The risk is undertaken by me. You don't work, you don't pay. No maintenance, no surprises. Fixed cost every month. Okay, just like your handphone. Supplier, has improved, upgrades everything. Okay, example, sometimes in technology, you'll see like Windows in the old days, 10, Windows from what, 95, 98, 2000, you keep upgrading, never end, correct? As a person who uses the system, why should you care? You should leave it to supplier to take care. So in this system, the supplier must take care of everything. But this business model can only work if the company is the guy who developed the system. So that means that the guy has developed capability to support you. Okay, this business model is called public-private. Model makes the customer center of business, and the supplier has increased quality by making failures expensive for myself. That means that failure becomes expensive for myself. This model in PUB is used very widely because I discussed with PUB. LTA also use a model because it's like contract model. In fact, the model is used a bit more in different agencies now because it shields them from the complexity of technology. Okay. In construction, in deep excavation, all this, you can see that in every time there's a next building, they have we call a diaphragm wall, and they have temporary struts. 25% of these temporary struts, they need to put a sensor. How many of you from construction site? None. Which group? Which company?
LTA,
LTA. You know this temporary strut, deep excavation. Which group you come from?
infrastructure design.
Design. Paul Fox group. Paul Fox group here. Okay. So in deep excavation, I do the temporary strut, real-time monitoring. Okay. This is the cell system. So in the strut itself, we have a sensor. Sensor go up to a data logger. This is a load cell. This is in Kim Chuan MRT depot, but now all finished. So inside there, they have a sensor, bring it up to a logger, 3G, send out. This is solar power. So this sort of system is Internet of Things, where the sensor is linked to the back end to a server through Internet. There's a wireless communication, and the users in the consultant, LTA, they can use Internet to log in to see all the graph alert system. In the system itself, we have sensors, data logger. Every 10 minutes, we upload the data, and the user can log in. So when there's an alert, it goes with handphone. This is a very old Nokia phone, so you see how old is the system already. This system was designed in 2001, pre-nickel highway. So the system uploads the data every 10 minutes. So the magic number of the 10 minutes for LTA, the instrumentation, the number came from me, 10 minutes. Because at that time, in the old system, they said real time, but they never specify how many minutes. Okay, real time is 1 hour. Okay, so the graph works like that. So as the sensor, the load goes up, it goes into over the trigger level. Within 10 minutes, it sends an SMS alert. Okay, so what we did was that we looked at the system from sensor reading up to the handphone in 10 minutes. Okay, so you can see that this is 2004 Kim Chuan depot. This is the actual phone itself. So this to handle crisis management when there is too much movement, people take action. So this is how we design system. You design an end-to-end one. You don't design. So the nickel highway system, why it failed is because they provide real-time. Is real-time data logging. Real-time they take the data store here, but they manually go and collect once a day. So I know that project when it went through the court inquiry. So in a sense, when they say real time, it doesn't mean real time. So it's the same as IoT. When we send sensors from all the sensors, it's immediate one. But because today the technology is much more sophisticated. Okay. Another one, this is called ATMS, tunnel monitoring system. In tunnel monitoring system, you know this before? In a tunnel, we put prisms, and then we have a tilt sensor of the tracks. So in this system, when people are doing excavation, the tunnel will move. So when there's a movement, if there's a crack, you damage the water lining, waterproofing lining. Cannot repair because it's 40 meters underground. You cannot patch, it's not like a house you can patch, because the water pressure is very high. So over there, we measure tunnel deformation. That means that our train tunnels, when it moves, we have light prism, so different segment. Then while they are building beside, they are very worried this tunnel moves because the tunnel is not secure in the ground. It's just floating in the sand. So I do this type of work. This was the system, I think, very long time ago, 2001, 2002. So I developed the system with another local company to do this type of work. Now, then, this was the biggest project I did. In Marina Bay Sands, while they're building these 3 towers, I had tilt sensors, strain gauges, 300 tilt sensors, 400 strain gauges, 400 temperature, where when you build like that, so at the end of the day, when it tilt too much, they got to compensate back. Tilt too much, they compensate back. The reason behind when they build it up, they must stitch at this point. This point, they stitch together, so it won't move as a structure. As a structure, if you leave it like that, it will just wobble. So when it goes up, they must stitch together. So during the construction, they got different angle. So they use this for construction monitoring. So as you build, you adjust. If you build, you adjust. So the reading we gave them can affect their construction cycle accuracy one. So they were depending on us to give them all the accurate measurement. For this project, it was very interesting. I wasn't the cheapest. I was competing with Tritech, and I launched an attack to attack their market, and that's how they buy me over. So to get them interested, I attacked. I beat them. They were lower than me, but I was more expensive than them. Samyong gave me the contract still, because Samyong told me I was the more reliable guy. I give them good quality data, because I emphasize on quality data. So it was very interesting because this was run 24/7, fully automatic, and I got staff 24/7 on standby in case system failure. So this is water. So actually in Singapore, if you look at construction sites, there are many sensors around. People do, and it's internet. They are all called Internet of Things. But unfortunately, those things are kept very quiet. The reason behind, when there's a problem, people don't want you to know. Or else when you put this, it surface problems, the mistake you make. So certain things people do is never made public. But because these were the projects I do, I can share with you. There are a lot of projects I know people do, just they don't put in public. Okay? So this is what we call for construction business. But there are a lot of other senses people do in construction. This is only what I do. There are a lot of other things people do also. It's just that it's not so much public information. Okay? Then in 2009, my customer bought over my company to move the construction business to their site. Because I was growing bigger and I became a threat. So there are two choices, fight with them or buy me over. So they decided to buy me over. Then that group, I think about 5-6 guys, moved to another unit in Tritech. Then I convert to water. So most of the time, government agency actually knows me in water more than anything else. So this is a flood monitoring system where there are solar panels, sensors, water. We have, at that time, I think now it's about 100 over stations in Singapore. Collect the data, send to a server. When it's out of, go out to alert, you send SMS alert. They can log into the website to see. So you see there's a flash flood. So this business also expanded when there was a flood in, I think 2010, in Orchard Road. In fact, when they first start, they don't have so many stations. The minute Orchard Road flood, they want to see how it flow, where the water flow, and become a key player. Sometimes it's just opportunistic. Okay. Now, the interesting part, I show them, I convince them to use this model. Every month, per station per month, they calculate number of hours in a month, divide number of hours not working, divided by number of hours in a month. 1 day not working, 1 hour not working, they divide, then you lose money. That means that if it doesn't perform, I get penalized. I'm paid to perform, which is correct. I mean, at the end of the day, you are paying me a job to perform, correct? So I should perform. So, share with you, this is the real one. All these are stations. That means at this station, I paid 99%, 86%, 77%, and 5%. If I don't perform, you penalize me. Okay, now I stop at this point. Why do you think I want to do that? Anybody can guess? No, from a customer point of view, he likes it, correct? But as a business owner, why I like it?
Keeps away the competition.
Huh?
Keeps away the competition.
That's one,
Recurring business.
huh?
It's a recurring business.
Correct. But for my organization, not. I give you an example. If I do this, my manager, he cannot collect money from this month. I talk to him, hey, Xavier, this month we lost money. Can you make sure next month we don't lose money? How many times can he come back and tell me we lose money? He will make sure it works, I tell you. Because I got monthly KPI for him. And I don't have to push one. This one measures his performance straight away. I don't have to push him one. He will chase. The system regulates itself. You see what I mean? Because when I have this system, it's very easy to articulate to a big group of people who are running the operation. You say, hey guys, we lose money. But of course, I don't get upset. I say, can we do something to prevent? Then there's a continuous improvement. Until to this point, every time 100% really. And you cannot fiddle the number because the client knows. They see it not working, they'll scream. So the system I have to do this is a good system because it makes the whole system vertically professional. Okay. Then after that, you go and see every reservoir in Singapore. I have this is a chemical laboratory. There's a company, there's a solar panel. The chemical goes down about 10 meters. Every half a meter they measure, move up, transmit back to the server. This is used for, all our reservoir is now close up to convert to fresh water, correct? Yep. this is one of them to monitor there are no chemicals in our reservoir for yours to drink. This was discussed with me because when the first project, when you first start, same problem. They don't know what they want. So I told them, why don't we try this first? Then after that, they gave me, for this one, it's a 5-year contract. So instead of paying like that, you tilt this way. You pay me every. Then I take the risk. I take the risk. But because I'm an engineer, my guys are all, we are an engineering company, we can fix problem one. Don't work, go and solve one. And this system today is duplicated in China. Okay. This is a command center in level 7 in PUB. This is the water system. Then I also got a camera system for PUB. So along the road you can see big solar panel. They put camera to see water surface flood. Because the sensor is for canal, road surface they use camera. And after that we also go to India. Same thing, water quality. I compete in the World Bank project in 2012 for 1,500. There are 10 stations here, and we got the tender. Then now they are calling, but I'm already out of the business here. I'm calling, I think, 170 stations in India. Okay, so the typical stations I have, that was in 2012. I have the privilege of information. Now I leave, I cannot. Different station, number of stations, number of parameters, how many minutes. 1 month I collect about 900,000 data points. 1 month is 26 million data points. Okay. So now what I suggest we do is that for the work study, I like you all to select one project where you think, let's say you form a group, you think about what application example you want to follow. Then, among the group, choose a possible business model, its pros and cons. Let me explain to you.